Example 7. Rewrite this expression as an expression that does not involve a fraction. Okay, so again, I'm going to just write down, I know I wrote it earlier, some rules. Now, we kind of have 4 rules. The first thing is you can always change to sines and cosines. That helps us oftentimes when we try to cancel things out, is change the sines and cosines. The second rule is we look for the Pythagorean identity. The third rule I mentioned. Well, the fourth is conjugate, so I'm blanking for a second. And the third rule, let me go back, it was factor. Yes, factor. Sorry. Factor. We can factor. These are the things that we look for when trying to solve. Now, this says try to get rid of the fraction. So that'll be easy. It's kind of directing us what to do. It wants us to get rid of this fraction here. Now, how do I get rid of this? How do I make this move to the top? Well, I use a reciprocal because a reciprocal flips something. So 1 plus tangent squared x, and then this would flip up. So no longer dividing, it would become multiplying. But what is CSC's reciprocal? CSC, when it's in the denominator, here it is the same thing as sine in the numerator. That's the reciprocal. So when I come over here, instead of being divided by CSC, I can make it multiplying times sine squared x. Again, this is reciprocal. That's what I did here. I did a reciprocal identity. So I didn't use these rules yet, but now that I got that, when I look at this now, I see a 1 and a squared. Well, oftentimes you see a 1 and a squared, you're going to have Pythagorean identity. So I'm going to look for the one with tangent involved. That's here. And it directly says that 1 plus tangent squared equals secant squared. So right here what I can do is I can say this, according to the Pythag identity, that is secant squared x. And so that would be multiplying times sine squared x. Now those aren't the same things, so they can't cancel, nor can they combine. But I do know this. Secant squared doesn't have to stay as secant squared. We can use rule 1, changing the sines and cosines. What is secant squared the same thing as? When I come over to the reciprocal, secant squared, when I want to change it to a cosine, that secant is the reciprocal of cosine. Or, if you look here, secant squared is 1 over cosine. So I can say this is 1 over cosine squared x times sine squared x. And that, we got this right here from the reciprocal identities, which is really changing the sines and cosines. That's all it often is a reciprocal or quotient. All right, so now, can I simplify that? Yes, I could. This simplifies to be sine squared x over cosine squared x. Now, if you know the song, psi y, cos x, tangent is y over x, that would help you out. Because this is y over x. That, ladies and gentlemen, is tangent squared. And that's my answer. Now, how did I get this? This step right here was the quotient identity. The quotient identity says that y over x is tangent squared, or tangent. So sine squared over cosine squared is tangent squared. And that would be fully simplified. Now I have one for you to try, given here.